Hey guys, how's it going? Hope everything's going good with you guys. This is Lightning Code and welcome to today's video. So today's video is going to be a continuation of the recursion topic. I'm just going to run through another example about recursions. Last time I went over factorials, so you could check that out. But today we're going to be going over binary search, which I think is also really useful. Getting to know binary search will help you transition into like other things that might be a bit difficult, but it's really useful. I think you enjoy it. All right, so enough with the preamble talk. Let's move straight into it. So we're making binary search. For binary search, it has to be the array we're searching through has to be sorted. So this would be a good time to pull up your insertion and merge sort skills. Yeah. But we'll just make a pre sorted array, and we want to be able to basically split whatever array we have in half and check if the number we're looking for is greater than or less than our middle number. So whatever number is in the middle index, if it is greater than the number we are looking for, then we want to check only on the left side where everything is less than that middle index. However, if the number we're looking for is greater than our middle index, then we want to check everything on the right side. This is a lot faster because you don't have to check every single cell. For example, you're looking for something that's at the end of the array. You don't have to go through every single value in the array to find it. Once you look at the middle, once you look at the middle and you're like, hey, this is definitely greater than what's in the middle, then you just look at only the right, or if it's less than what's in the middle, you look at only what's in the left. So it's really fast, really helpful. All right, let's get into this. So we're going to wrap this in a function, and we're just going to call this binary search. And it's going to take the array we want to search through, the left, like the left endpoint, and the right endpoint, and it's also going to take our target, whatever we are looking for. Now we first want to make sure that we haven't gone to the end of our array. So like we want to make sure we haven't gone to the end of our array, so that we don't just like make it crash and like keep looking for what isn't there. So we're going to say if the right endpoint is greater than or equal to 1. So that means, like, let's say we're starting as our left starts from 0, the 0th index, and our right index is 1 or more. That means that there isn't just one thing left in our array to look at. So we want, if the right is greater than or equal to 1, we want to get the middle. So we're going to make mid is equal to left plus right endpoint by 2. So this is floor. This is like I'm flooring it. I'm making sure like it's an integer. I don't want to have to deal with floats because we can't move down the array with a float with an index of a float. It has to be an integer. All right, so that being said, the first thing we want to check is, since we've divided our array into 2 and we've gotten our midpoint, we want to check if what we are looking for is actually in the middle. So it's equal to target, and if it is in the middle, then we just want to return the index of where we found it. However, if it's not in the middle, let's say but like now let's do the other condition. Sorry, if it's not in the middle, let's check if what's in the middle is greater, I didn't spell mid there, is greater than what we are looking for. So if what's in the middle is greater than what we are looking for, then we only want to check everything on the left. So we're going to call this function recursively, and we're still going to pass the usual things, the array we want, from our regular left endpoints, but this time instead of going through the whole thing, we are going to stop just short of the middle and still give it the target that we want. So we're not going to look through everything on the right. We're like, hey, it's definitely bigger than what's in the middle, so that means what we're looking for in the sorted array is definitely on the left side. So we're just going to check from the beginning to right before the middle. Then in the scenario where it isn't that, all we're left to do is, that means it's going to be that means our target number is greater than the middle, so that means it's everything on the right. So we just binary search again. This time we're going to be starting from like just past the middle, so that's the mid plus 1, just past the middle index. We are going to the right endpoint. We still give it our little target. Awesome. Now this is the scenario whereby we are still looking for it. We need to put an else statement to indicate if we didn't find it. So we're just going to return -1 if we didn't see it, like, hey, we didn't find where this stuff was. So this is pretty much it. Now, as I always do in my channel, I always like to test things out to see if I messed up or not. So let's test it out. Now, let's just make an array. We'll call you Ari. Yes, that's what we'll name it. All right, so we're just going to make a simple array of now let's say 8 and 9. Good. Spaces, spaces, spaces. Oh, yep, more white space issues. All right, I think I've got all that handled. So now we want to so let's say what we're looking for is x, and we're looking for the number 3. So we're just going to call binary search on. I want to call binary search on that. So we'll save this as results to hold the value. We're going to binary search, and we're going to give it Ari, our array. I was starting from 0. Let 0 be our left endpoint, and then let this be the length of our array -1. Because if we have 5 elements in our array, for example, and we're starting from 0, that means the indexes are 0, 1, 2, 3, and 4. So we don't want to put 5 here because then it would go over. We want to stop at the 4th index, which is actually the 5th value. And the last thing is x, our target. So we want to print where we found it. So we want to print results. So if this works, we should get it at the first index. So this is 0, this is 1. All right, so let's see. Let's how many numbers I have here? 1, 2, 3, 4, 5, 6, 7, 8. All right. Let's run it and let's see. Nice. So the first index 1, which is actually the second index, sorry, but the index of 1, that's where 3 is. That's great. Now let's say we're looking for 6. Well, what do we find? Great, so it says it's in the 4th index, so we have 0, 1, 2, 3, 4, and that is correct. So why don't we add something else? So 6 is now going to be in the 0, 1, 2, 3, 4. It's still in the 4th index, so we still should get 4. Great. Let's say we're looking for 10 now. We run it. 10 is in the 8th index, so 3, 6, there are 9 things. That means the 8th index, as this is the 0th index. So that's it for this video. I hope you have a handle. like a better understanding of recursions from this, like and subscribe. If you haven't, hit the notification bell so that you can get notifications of when I post, and leave a comment what you liked, what you didn't like, what you think I can do better, and what you'd like to see. And as always, you guys are doing awesome, you're doing great, and thanks for watching.